when changing the organoleptic properties, customers will buy the product? No, you want to have the product that you like. If the product is not with the same characteristics, no one will go buy it. Then using production of kefir. You know the kefir, right? Okay. We was isolating, actually Gillian, one of the students, was isolating this strain Lactobacillus plantarum, ST8 kefir. So yes, remember the Santosh was telling you can put your initials in the strain. So ST actually standing for my initials. 8 was isolate number 8 because we have 1, 2, 3, 4, 5 up to, I'm not, I think something, 40 something in this case. And Chi F is stands for kefir. So normally in our collection, when I see the strain, because of these last two symbols, I can tell you from where it's coming from. Because it's helping. I mean, I'm going to remember all the strains that you have in the lab. So you need to have some easy way to remember. Okay, with Gillian we isolated this strain from kefir, and then we wanted to reincorporate in the kefir grains. So we was taking a kefir grains that we not detect any antimicrobial activity, and then we reincorporate the strain inside the kefir, and we made it a test. We made it a kefir contaminated with Enterococcus. So you see the normal known presence of Enterococcus, not contaminated with Enterococcus. This one that was with mutant that not producing bacteriocin, and was strain that producing bacteriocin, because we cured the plasmid as well in this strain. So obviously you have some Enterococcus, but much more decline the number of the Enterococci when bacteriocin strain is produced. And the Enterococci could be a problem and could be a serious problem. In this case we use the non-pathogenic Enterococcus that is showing that is safe, because we wanted as well people to try the products. Obviously you're not going to give the sensor panel something that is dangerous. You want these people to be happy and to evaluate. Safety is important. Very often when you produce something for a sensory evaluation, it's even made it in a separate laboratory, because to be sure that no risk for contamination. It is, there was appearance of the sensor panel was saying that they cannot detect any difference of presence of our bacteriocin producer or not. In another experiment done by Eva Bala, it's a colleague from Hungary, that was Hungary, that was isolating two-component bacteriocin. In this case, the bacteriocin produced by Enterococcus faecium, isolated from fecal samples from piglets, was having these two enterocins, A and B. So, two of them, they need to be present as a complex in order to have the activity. I told you these bacteria are very difficult to work because you need to be sure that two of them are together. If one is missing, no activity. But then she was using, showing that they have a good activity against several pathogens, Proteus vulgaris, Staphylococcus epidermidis, Listeria innocua. And now Listeria innocua is a strain that you can, it's not pathogen, but it's a very good model for Listeria monocytogenes. So you can work always with Listeria innocua, and you can transfer your results to Listeria mono very easy because they interact in the same way. Remember that Listeria monocytogenes is a foodborne pathogen. You have the Listeria on your microbiology course or not? Listeria monocytogenes is very dangerous for pregnant women, small children, elderly people, and immunocompromised persons. And it's intracellular pathogen that actually can kill. It's killing every year, killing several people. This is why it's ready-to-eat food. It's supposed to be free of Listeria monocytogenes. It's unacceptable to be present in your food. And imagine, if you work with Listeria monocytogenes, you have the student, female student pregnant, she cannot work there because it's dangerous for her. And you need to have appropriate laboratory equipment. And then this is why very often we use Listeria innocua as a non-pathogenic strain, and it's much more easy to work. Okay, so we made an analysis to see what concentration of the bacteriocin needed of this combination of these two in order to kill the listeria. You see, the small amount, there is no killing. This is a happy listeria with no presence of the bacteriocin. You have listeria in a very small amount, little bit more, little bit more. And interestingly, it was working well with a reasonably not too high concentration, always determining arbitrary units per ml. This is, I asked you several times to calculate this because it's important, not just the millimeter of inhibition zone, but as well the quantity of the. So we made it a fish pate and wanted to see if we can biopreserve the fish pate. The problem, this product, it's a sell in South Africa. It's a fresh product. It's not how they call preserved. So normally it's like 5 to 6 days shelf life. And by adding some of the bacteriocins in the formula when we was producing this fish product, we was able to extend the shelf life with 3 days. Well, 3 days you can say it's not too much, but product that have 6 days go to 9 days, this is like 50% extent of the shelf life. And for the supermarket, this was actually a very good idea. Several other bacteriocins being isolated from different cheeses in Bulgaria, and some of them was showing even activity against Escherichia coli. And we was studying some of them, trying to find a responsible receptor for the bacteriocin, and it's some work that is still going because sometimes it's not very easy, but we are not giving up, and we're going to have what we want. So the important take-home message that the lactic acid bacteria from dairy products have the enormous potential to reduce the spoilage and other foodborne and spoilage microorganisms, and they're important for the hygienic quality of these products, because obviously we don't want spoilage microorganisms, we want the stability of the products, and we want to be sure that all these products will be having safe and appropriate appearance. Then we wanted to know again another project. We use this Bulgarian cereal-based beverage called Buza. It's extremely popular in Balkan Peninsula. And a lot of people know the traditional medicines, different suggestions, what can apply. It's helping, it's a very rich on the lactic acid bacteria. It's a rich of yeast, having a lot of level of vitamins. It's helping small babies to grow. They even sometimes use it as a replacement for milk. I mean, not a full replacement, but one of the milks could be this product, because baby need a milk, no way. There was recently one story, the couple, they killed their baby because they was giving the baby only shea to eat. Come on, baby on 3 months old needs some mother's milk. Or if the mother don't have a medical problem, well, animal milk, but needs some milk. And they was giving just shea, and baby passed away. Okay, but some of the milk you can give it. It's reducing the diarrhea in the babies. It's helping with in the situation as a protection during the influenza outbreaks. Helping in the traveler's diarrhea, it's reducing, just because it's very rich of lactic acid bacteria, rich of the yeast, the vitamins, and other bioactive products. So normally how it's produced, you have the grains, you wash them, you add the water, you boil, you mash, you add a little bit more water, you ferment, you add sugar. Well, bacteria like a sugar, they don't want a sweetener. So very often this kind of products, you cannot make it light or diet, because bacteria, it's not as stupid. They want the sugar. To grow, they need sugar. Sweetener is not working. And using the different starter culture, okay, you can see sugar or saccharin, you can make a combination, but sugar needs to be present. So we use the starter culture, it's natural fermentation, natural fermentation. We was using the Buza from the previous batch, like normal procedure. How do you make a yogurt? You're using yogurt from the previous fermentation. How you make several of these fermented food products? You just use the old product. And then we used Lactobacillus sacchi that was sensitive to the bacteriocin that we were studying, multicin. Was sensitive, Lactobacillus sacchi was sensitive to multicin because we wanted people to try the product. And obviously you cannot use the pathogen in this situation, right? So we used the safe strain as a sensitive, And we was using Enterococcus multi as a bacteriocin producer. So we have all this combination. We made it more or less evaluation, how it's growing, how it's behaving. Nothing unusual. All these batches was giving normal growth, normal acidification, all these processes. But then we wanted to see which bacteria is there, which bacteria survive. So we used the DGG. Someone is familiar with the DGG? Okay, DGG, you make a PCR. You target GC fragments. And then you put in the gradient. Gel is made as a gradient. They have denaturation properties. So when the PCR product is going, and when it's coming to the specific position in the gel, we will be denaturating the PCR product. And you can observe or not observe the PCR products, and it's like a kind of pattern that you can actually, if you have the same pattern, you have the same thing like a control. Very often it can be used for mixed population, and you put your mixed population, the gel, and you have the pure cultures DNA, PCR, and you can compare to see what do you have. It's a very approximative, it's not very precise, but it's quite easy to perform and giving you a reasonably quick answer what do you have. So we have the first Boza made by starter with Boza. We have this same product but contaminated with the test microorganism, natural spontaneous fermentation, and again contaminated with the test microorganism, starter bacteriocin producer, and starter bacteriocin producer and test microorganism. And then we have fermentum, saki, fecalis, plantarum. This is supposed to be, this is our strain, ST4, control strain. So we was doing a DG, we took a sample for 3, 5, 7 days, and we was performing and see what we can see. Interestingly, Enterococcus multi, his control, it's present on when we have starter culture Enterococcus multi. It's logic, we put this strain, but nothing here. It's again logic. Enterococcus multi is not something that you can find anywhere. Then coming to bad news. Enterococcus fecalis was having the same position as a multi. So now, how can you tell me this is fecalis or multi? It's difficult. Well, we know we have multi, Enterococcus multi, so we presume, but again, it could be contamination with fecalis. Then Lactobacillus saki, our test microorganism, we can detect in the most of the samples when we add it, but we can detect in some of the other. So look like in this case we have kind of problem. We cannot really conclude we have the strain or we don't have it, what's happening. It's a little bit kind of on the shadow. It's not clear. So obviously, only one method is always be a problem. It's another important thing. When we do this experiment, we was taking care to work, we work with the DNA, and then we realized, but DNA you can isolate from the dead cells as well. So you need to take care to have the DNA only from live cells, because maybe a strain died there and it's still DNA is there. Very often when you just work with the DNA, you're having this risk to work with the dead cells DNA. And we want to know about live cells. So you have two options. You can work on RNA level, or you can use some modification in the DNA extraction when you block the DNA from the dead cells and you isolate the DNA only from live cells. Well, the dead cells are there having full of destruction, and you use some of the chemicals that can make a contact with the DNA, and when you isolate the DNA, you isolate only from the live cells. But then we was actually worried because of same position, some presence, and we was performing simple PCR with the species-specific primers, targeting specifically Enterococcus multi, targeting specifically Enterococcus fecalis, Enterococcus faecium, only plantarum, all these things. And based on the species-specific primer analysis, together with DGG analysis, we can actually conclude that in our product, Enterococcus multi, bacteriocin producer, is growing very well. He's feeling like at home. He liked the environment. Well, we tested before to see that he's really happy with this environment. But again, can produce the bacteriocin and can kill test microorganism, use it in this case. Again, we performed a series of experiments showing the organoleptic properties. Now it's a kind of discussion, which one is the better? Trained panelists on just the consumers. It's always a discussion which one is the better. So we use some of the people as trained, some as just random students that show the interest. And then checking the yeast aroma, bitterness, sweetness, yeasty flour, acidity. All these results are showing, in fact, consumers cannot detect presence of the bacteriocin producer in the product, and they are happy, equally happy if it's produced with the starter culture, previous Bozar, or if it's produced by the starter culture Enterococcus munti, that was bacteriocin producer. But important thing, in the next step of the experiment, contaminate the product with the listeria. It was able to reduce listeria. In fact, it was not detecting listeria when Enterococcus munti being used as a starter culture. Can we go to these examples of mastitis, and then we can have the tea break? Are you agree? Okay. Well, the tea is a magic word. Everyone like it. We was using again this Streptococcus galolyticus subspecies macedonicus that was showing that was using to explore the anti-mastitis property. But now we're getting a little bit further. We was making using a yogurt as an idea, because very often mastitis pathogens can be transmitted. Some of them can be even detected inside the yogurt product. And if you have them, imagine you don't want the yogurt with Staphylococcus aureus. You don't want it, because I mean it's a really bad. They can even produce the toxin. And you eating a product with the toxin, and 1 hour, 2 hours later you run to the toilet because you will be with diarrhea. When intoxication is very quick, most probably it's associated with the production of the toxins, and it's passing quite quick. It's not too bad, but again, it's not pleasant. I mean, no one's wants stomach problems. So we made it a simple again test with the DGG. In this case, we have the single cultures, 1, 2, 3, 4, 5, 6, 7. Single cultures of bacteriocin producer and 6 different pathogens associated with mastitis. Yeah, it's here. Wanted to see this arrow. And then we was checking after 12 and 48 hours, taking care to be sure that we're isolating DNA from the live cells. And then we was having a sample when all of them, bacteriocin producer and 6 pathogens, was putting together. So DGG again, this actually 1 to 7 is our control, it's our pure cultures. There is their DNA pattern. And here it's a mixed. So you can see that our strain, it's present. It's okay. Well, the problem, the pathogen number 3 has presence as well. But the pathogen number 2, pathogen number 4, then the pathogen number 6 or pathogen number 7, that was gone. Again, bacteriocin is not something that will solve all the problems. But again, we're reducing big part of the pathogens that we was adding. So in fact, we was reducing risk of contaminations, and applying the bacteriocin producer can actually, as a starter, and remember, this bacteriocin producer was isolated from this kind of yogurt. So obviously it's a strain that is comfortable in the environment. Well, Gillian made some work showing that the strain have the technological properties, even can be used as a starter culture. Well, to be called yogurt needs to be Streptococcus thermophilus and Lactobacillus bulgaricus. In this case, starter culture, this could be a jam culture, not a principal, or can be called just fermented milk, but cannot be called yogurt. And then obviously can help in the potential presence of the pathogens to be reduced. Can we have a break now? And how long? 30 minutes or less? Or more? Okay. If you ask me, I will cut it to 10 minutes, the break. Sorry, it's... Okay, so please go take a tea and enjoy, and in 30 minutes we continue.
Wanito biar.
recording? Okay. Well, they tell me that I need every time start when it's recording, not before, because it's some people assisting from outside. Okay, another examples of application of the bacteriocins. In this case, we have the isolation of the different strains from goat milk, and taking samples of milk samples from organic farmers close to the Sao Paulo city. I don't know how it can be organic, because the air is so polluted in that Sao Paulo area. Well, but it's quite far away from the city center. It's a rural area. They have small farm. Milk, we took a sample, so we isolate several strains of these milk samples. They were showing production of the bacteriocin. Most of them was identified as Lactococcus lactis. Some of them was Enterococcus herae. We made a property analysis showing that it's the different strains. Always when you isolate several strains from the same product, do the RAP PCR or RAPD PCR, because you need to be sure that you have the different strains. You don't want to waste your time working with 10 times with the same strain. Rather, check you have different and to be sure what you have. Interestingly, most of them was producing niacin, showing 97% homology to the niacin. And interestingly, when we transmitted from DNA to protein level, was even some mutants, some modification of some amino acids, 1 or 2 amino acids, different from the niacin F. And we wanted to see how actually we can use this strain to make a cheese, and if we can use it as a biopreservative for the cheese production. So we're having one cheese in Brazil. It's called Minas Frescal. It's fresh Minas cheese. Minas Gerais is a state of Brazil, and it's famous by the dairy products production. Fresh cheese, because this cheese is produced, is coagulation process, and then cannot maturate. Very similar to the feta cheese that is consumed in Greece or Bulgaria, but feta is maturated. This one is fresh. Normally the process is very simple. You have the milk, you pasteurize the milk. Well, now, cheese made from pasteurized from raw milk, it's a big discussion all around the world. The problem is several foodborne pathogens can be in the milk, and if you don't pasteurize, you have risk to have these foodborne pathogens, and they will be later in the cheese product. From the safety issue, it's better to pasteurize. From the consumer's perspective, they say, but it tastes better if it's non-pasteurized. But well, better to be safe. We can compromise sometimes a little bit with our taste, but we don't want a disease. So we pasteurize the milk. We add the ingredients, that is a little bit of calcium chloride, lactic acid, and we add with the rennet. It's a commercial rennet, the coagulating enzyme, to make the coagulation process. Then you cut, you stirring, you make a filtration to go rid of the weight. So to make it, then you put in the form, you press, and you make a short period to eliminate the water, the weight, and you put the salt, and you have the cheese, and you can consume it fresh. It's quite pleasant. So we actually asked different cultures to see our experiment. We used the Lactococcus lactis as a co-culture, but as well we inoculate with Listeria monocytogenes to see if we can destroy Listeria. Because very often this cheese is associated with presence of Listeria, and if Listeria is present, you cannot sell the cheese. So obviously it needs to be Listeria free. But dairy products are very easily to be contaminated. Another problem with Listeria, that Listeria grows 4 degrees Celsius. So you make your dairy products, you keep it in the refrigerator, you think you are safe, but no, Listeria making part in the refrigerator and growing, and then can actually, it's true, Listeria can kill you. It's a quite dangerous pathogen. So you don't want a Listeria in your food product. So we made it cheese just with Listeria to be sure that Listeria can grow well. We made it a cheese with Listeria and Lactococcus lactic bacteriocin producer. We used the ATCC Lactococcus lactis as a bacteriocin negative control, and we just put our strain without Listeria and just nothing, because we wanted to know if everything goes well. So everything was having a good cell count. When it's nothing, there was nothing, so it means it's a well pasteurization process. Every work very well septic. So from this point, everything okay. Now we wanted as well use pure niacin, commercial niacin in fact, as a control to see what is going. So when we was doing cell count of Listeria, when we was using commercial niacin, Listerian niacin, this is this line, you see Listeria disappear. Well, this is a good point, but this is why niacin is applied to kill the Listeria. In our control, like quality control, there was no bacteria, it's normal. Now coming the problem, look here, first one, it's a growth of Listeria. Listeria grow very well in this kind of cheese. But then, if you use Listeria together with producer and non-producing Lactococcus, they don't give significant difference. They're acting in the same way. Well, they're reducing 2 logs of Listeria, but there was no difference on this bacteriocin or something else. So, because bacteriocin positive, bacteriocin negative, they act in exactly the same way. Now you can say, but yeah, but we still have 4 logs. The question is, we made this experiment at a very high level of contamination to observe better. When we repeated the experiment with like a 1 log, that is more logic contamination that you can have in the industry, 1 or 2 logs, we was not detecting presence of Listeria in the presence of 2 Lactococcus lactis bacteriocin producer or Lactococcus lactis that is not producing bacteriocin. So actually it's a little bit disappointing because you have the bacteriocin production, but you don't really act much more different. Strains that don't produce bacteriocin as well acting the same way. So, well, it's quite interesting results, not too bad, but not really proving that bacteriocin is working well. So we went for second experiment. We took Enterococcus multi, strain isolated from yellow cheese in Argentina. And this strain I will refer now in the next few slides as Argentinian strain. And we have Enterococcus faecium isolated from cheese obtained from the local supermarket in Sao Paulo. And I will refer to this strain as a Brazilian strain. It's much more easy instead to tell them names. So both of them, they grow quite well. This is Argentinian, this is Brazilian. Now observe here the activities. 25,000 units is 6,000 units. So the Argentinian is producing much more than the Brazilian. Well, in Brazil and Argentina it's a big fight. Who has the best football? Who likes the soccer? Not really, it's cricket here, I know. But they have Messi, that is one of the biggest soccer players in Argentina, and in Brazil was Pelé. And all the time it's the fight. It's Messi or Pelé the better one. So if you say in Brazil something good for Argentina, they'll look for you very strange. But well, Argentinian strain was performing much more better than Brazilian strain. Then we wanted to see how we can kill Listeria. We used the 4 different Listeria, monocytogenes, 4 different strains. And you can see that both strains, Argentinian and Brazilian, they're killing quite well. In this case, strain from Brazil, this is the Brazilian, this is the Argentinian. So in this specific Listeria, Argentina performed better than Brazil. In this specific Listeria, again, Argentina performed better than Brazil. In this case, it's almost the same. But already all these tests were showing that most probably Argentinian strain will perform better. Why I'm doing all this? To showing that you don't need to jump to make a cheat, because it's a lot of work. You can take several steps before to decide which strain you can apply later, because all these tests will show you which strain have the better potential. Then we do the absorption of the bacteriocin to the producer cells, to the different test organisms, including effect of different chemicals and pH, milk, sodium chloride, how this presence of these chemicals or pH or different will interfere on the absorption of the bacteriocin. Because remember, this is the test microorganism, this is the bacteriocin. Bacteriocin needs to attach to the surface in order to do the job. So you can explore this absorption and decide with which condition will work better, so to know what you can use. Everything done in 20, 30, 37 degree 20, because normally this is the temperature they keep the cheese before putting in the refrigeration in the normal production process. And then everything was showing that the Argentinian strain will have the better potential to work, to kill listeria compared with the Brazilian strain. So we made it a cheese the same way like the previous, with the Argentinian and with the Brazilian strain. So when we was doing effect of Brazilian strain on Listeria monocytogenes, you can see that Listeria, this one, the green yellowish, is growing quite well. Well, it's normal. Listeria like the dairy products. However, when we was having the Enterococcus faecium, Brazilian strain, together with Listeria, we was counting presence of Listeria, well, quite a reduction, not bad. And when we was counting Enterococcus as our producer strain, in co-culture with Listeria, but we was expressing the number of our Enterococcus, he was happy as well. So technically, the Listeria alone grow very well. Strain of Brazilian strain is growing very well, but then reducing the level of Listeria with almost 3 logs. Not bad at all. I mean, 3 logs is a reasonably good result. Just remember, more or less 3 logs. However, when we do the Enterococcus fecalis ATCC strain, that is no production of the bacteriocin, we was having more or less the same results. 5.3 to 8.3, 3 logs again. Well, the strain is not producing, this strain is not producing bacteriocin, but he's still reducing the level of Listeria, because the greenish one is 8.15, is the number of Listeria alone. Here it's a Listeria in the presence of the non-bacteriocin producer, but it's always the same results again. A little bit disappointing again, because you have the bacteriocin production, but they not differ too much with the other lactic acid bacteria. But then when we do the Enterococcus munti Argentinian strain, you see the difference now. We're having 5 logs. But already with all the tests when we performed before, we were showing that Argentinian strain is so better, he reacts better, he kills better, and in fact when you do the cheese, we have 5 logs difference. That is very good result, because if you're reducing 5 logs up to the contamination, 3-4 logs contamination, you can have practically elimination of this contamination from the food product. So obviously, preliminary results are very important to see how they absorb, how they kill, are they don't kill, how the pH, temperature, chemicals, in this case milk and sodium chloride is important, and to know how this environmental condition will interfere, will modulate the antimicrobial activity. And then you save a lot of work, because making cheeses is quite heavy work. It's kind of a lot of material and counting and spending nights in the lab. So rather check all these things first on the plate and then you do your cheese. So the moral of the story, we can do the pre-selection, we can have the strains that can be able to inhibit the Listeria and even eliminate fully Listeria from the food product because of the production of the antimicrobial peptides. Another important thing that needs to be touched is bacteriocin producing lactic acid bacteria with antioxidant property. Remember, by definition, lactic acid bacteria are catalase, positive or negative? Negative. And they need to have a different system for the antioxidant properties. So they can be different options for the different methods to explore the antioxidant properties. And in this project, we took fermented vegetables. Does it look familiar for you? I mean, it's very typical in Bulgaria. And now you're telling me it's typical in India. But it's very normal. People prepare this at home. We have it in the supermarket. We have it homemade. But in this case, we were targeting fermented vegetables prepared from the family, doing for them all. There was no industrial, there was no chemicals, there was even using high mountain spring water to use for the water. So you really made it for yourself. You don't put any preservative, nothing dangerous. So what was interesting to observe, the microbial load is not very high, 10 to 4, 10 to 5. that is considered like a reasonably very low microbial load. Because fermentation process occur, it's a very, normally not a very long fermentation process, but again, they're keeping it in the cold, in the basement normally, consuming all the winter. And then we wanted actually to see what we can isolate with as a bacteriocin producer. We was using exactly the same approach that we was doing with me in the laboratory. And we was able to select several strains and showing that it's a different strain because identification was showing Lactobacillus plantarum, 4 different strains. By direct PCR, we were showing that they're different strains. We have Lactobacillus curvatus, Lactobacillus paracasi, Pediococcus pentosacels, Leuconostoc, and Enterococcus faecium. Sure, we check safety for all these strains. We confirm the identity by the 16S, by the RAP PCR. We was doing even AP50 to know what is their fermentation profile because we wanted to know what kind of sugar they can ferment. And we was confirming for all of them, they have the antimicrobial properties. All of them was gamma hemolytic, there was no mucin degradation, there was no gelatinized activity, there was no lipolytic activity. Because we wanted really to be confirming safety of these strains and this way confirming safety of the food products, and as well in future application to know that they're safe strain. Antibiotic resistance as well. But all of them was showing interesting, very interesting antimicrobial profile. Okay, this is our producers. Okay, now you see that you already recognize my way of naming them. ST, number of the strain, BG, it means Bulgarian vegetables. Okay, so we test against Listeria monocytogenes, 7 of 7. We test 7 different Listeria, all of them being inhibited. Well, no, this one. This one inhibit only 4 from 7, this 5 from 7. Listeria innocua as well, 1 of 2, 2 of 2. Enterococcus faecium, most of them 5 of 5, but some of them less. Well, again, you don't have panacea, you don't have something that will do all the job, so you need to explore. And Staphylococcus aureus, some of them was working well, some not at all. But if you go down, Plantarum, Corvatus, Pentosus, Mesenteroides, all these things, you see they rarely having activity against other lactic acid bacteria. Well, some of them against Plantarum, but nothing against Corvatus, nothing against Pentosacels, nothing against Mesenteroides. Vancomycin resistance Enterococci, when we check, 12 of 40, some of them. Some of them nothing. Well, again, you don't expect to have to kill anything with everything. Lactococcus lactis, no one. Escherichia coli, nothing. Salmonella, nothing. Klebsiella, nothing. Okay, but bacteriocins normally are active against closely related. But no problem, rather check against some other pathogens. So resistant to common antibiotics recommended by EFSA. Remember, sempre, always we need to look about this recommendation of EFSA because it's saving work for us. There was reasonably under norms, nothing special, no chemolytic, no gelatinase, no production of biogenic amine or mucus degradation processes. Here it's antibiotic resistant profile. You see, most of them there was have sensibility to antibiotics. In some cases, again, there was some resistance. But when we was analyzing, this resistance was to interesting antibiotics. So from the safe point of view, they can consider it okay, no problem. Then, and remember, I was telling you this story yesterday, some research group these days, they defend the idea that reasonably moderate resistance, in fact, could be a good option. So you can use the probiotic together with the antibiotic, but it needs to be located on the chromosome, not on the plasmid. And we wanted to know how this strain will survive gastrointestinal tract. Because in order to perform something bad in lower part, they need to survive. So some of them was showing reasonably good survival. I mean, going from log 10 to log 8 is not bad at all because you still deliver log 8 in the gastrointestinal part, so it's enough. Some of them going down. this is why you need to do it, because in this way you can select the appropriate strain for the appropriate food. Because strain can be excellent, can be clean of virulence factors, can be producing very strong bacteriocin, but if it's not surviving passage via the gastrointestinal tract, you need to look how you can protect it. Maybe encapsulate, maybe doing a different way of application. So you need, as a scientist, to find a way to improve this survival and to deliver appropriate strain to the appropriate place. Or if it's not working, just look for another strain. Then we wanted to see how actually work these antioxidant properties. So, but first we check the hydrophobicity, because why hydrophobicity is such an important point. Normally, high hydrophobic properties is associated with a good chance strain to have the adherence to the cells of our gastrointestinal part. Well, it's not 100% true, because in some cases it's not work like that, but it's already a simple method that you can do. You just make your cell suspension with the N-hexadecan. You leave for the time to separate two phases, because N-hexadecan don't mix with the water. After separating, bacteria, if they like the water, they will stay in the watery part. If they don't like, if they're hydrophobic, they will go to the N-hexadecan. You measure the optical depth. It's a simple method. It's taking very short time, not too much material, and you already have the idea if you're on the right or wrong direction. However, interesting point is, now I want to know your opinion. The strain, probiotic strain, need to stay in our gastrointestinal part or not? Need to colonize or not? Okay, please, who think the probiotic strain need to colonize gastrointestinal part? Left hand. 1, 2, 3, 4.